Stop that. Start. All right, guys. Oh, I lost somebody. I was so excited. I just had somebody join and they left. They were grossed out about my ammo. I don't blame. Anybody else? So there are two things I want to talk about right off the bat. And let me just jump into those because maybe other people have questions about this. And then I'll see if people have other questions. So there was a request to do a problem sort of like 5, 6, and 7 in section 1-8. So let me just show you the problem real quick, and then I'll do something on the board. So there's a request to do one sort of like this one, which is where you have to create the Venn diagram. They give you the numbers you need. So I'm going to do one like this one up on the board. And then there's another question about, oh yeah, there's a thing I got to talk to you about, but I'll see if there's more questions.
Hey, Jeff, when it comes down to the homework, you want us to insert the diagram?
Oh, you can just recreate it on a piece of paper, no worries. Or you could do it in the book and take a picture of that. Yeah. Since it's all pictures you submit, you could take a picture of whatever you're working with.
But you want proof of the diagram or?
Well, you got to submit the diagram. That's the answer to the question, right?
Okay. All right. I guess that's an obvious answer, right?
Yes.
All right, cool. Cool.
All right. I'm going to try. Oh, man. See, more people are logging in, so it gives me a chance to do this. All right. There's some more people. Good, good, good. I can do this. Any of your other teachers have whiteboards like this? I'm so happy I got this thing. All right. So let's say that, let's see. All right, so let's say there's 36 people in class. Let's say that 25 of them live in San Diego. And let's say that 17 like the Chargers, right? Still after they moved away. And let's say that 12 live in San Diego and like the Chargers.
And who's your home team, Jeff?
What's up? Oh.
Who's your home team?
My life is rough. I like the Dolphins.
Dolphins?
Yeah. I grew up in Miami when I was a little tiny kid, a little tiny baby kid. And anyway, so yeah, my life's been rough. And I like the Celtics in basketball. So my life from 1985 until 2008 was very, very, very difficult. Anyway. Yeah. Oh yeah, just horrible, Jeff. Oh man, sports is the number one thing about making life difficult. Anyway, sorry. First world problems. So pretty cool with what's happening here. This is just like number 5, 6, and 7 in the homework. And they give you this, and let's say that the blue thing is Chargers, and this red thing is San Diego. So what goes, so the thing I tell you is the one that is both is the one you want to start with. Where will 12 go in this picture?
In the middle.
Yes, in the intersection, I love it. Now how many total is supposed to be in the red circle?
25.
So how many should I put right there?
25.
25.
No, because then there would be 37 total. There's already 12 in there, isn't there?
Oh.
So how many should go right there?
25 take away 12, I guess.
Right. That's right. Because now how many is in the San Diego circle? 25.
25.
How many is supposed to be in the Chargers circle? 17.
17
already
take
how
away
many?
12, so it's 5.
And there's one last number you got to put in. What's going to go out here?
The remainder of after that's 25, 30, 6.
Yes. You guys see what he did? You guys see what Linnell did? How many total people do I have so far? 25 plus 5 is 30 people. There's 36 total. So it's going to be 6 out there. Start in here. Then you get this. And you get that. And then you figure out what that's going to be on the outside. Who are these 6 people?
They don't do either.
Yeah, they
They
don't
don't live in San Diego, or they don't like the Chargers.
And so they don't live in San Diego and they don't like the Chargers. Because who are these people? Who are these 5 people?
They like the Chargers.
But
They don't live in San Diego.
there you go. Okay. Right? You guys with me?
Yeah.
So it is always a little freaky to know where, if you know where to start on a Venn diagram, you start inside and you work your way out. If you try to do it the other way around, it's never going to work. You're going to drive yourself a little insane. Or, more insane than we already are. Okay. Is that all right, guys? Is that good that's 5, 6, and 7 in section 1.8. That's the example that's just like that. All right. Okay, so while I'm up here, what have I said? What is SD and C? How many people are SD and C?
How many people are SD and C?
17.
No.
Yeah,
Wait,
18.
was it 13 or
No.
12? Go.
25.
They have to live in San Diego and like the Chargers. They have to do both.
12.
12.
12, yeah.
Which is another reason this is called an intersection, which makes complete sense because where do the 2 circles intersect? There.
Middle, yeah.
What if I say San Diego or like the Chargers?
San Diego.
18.
Well, now when I say or, if I said Bobby and Billy, Bobby or Billy, either one, clean up the room. If they both clean up the room, did the room get clean? Yes. So or doesn't mean not and. Or just means more than and. So what am I saying? Whoever said 18, you why did you cut these people out?
12.
So a total of
30.
30 people live in San Diego or like the Chargers. Of course, I'm going to include the people that do both because they do at least one of them. That's another way to look at or. You have to do at least one of the things. That's why, so that leads right into my next thing. Right? Let's talk about nightclub. What's up? You guys all right? Somehow, nightclubs plays into this. You ready? Am I ready? I don't know. If I go to the club and at the door there's a line. So I go up to the bouncer and I'm like, dude, come on, what the hell? And he said, all right, to get into the club, you've got to be rich. Shit. Or I perk up, don't I? I perk up. I got a chance. Or you got to dress nice. Shit. Or, okay, I perk back up, right? I perk back up. He says, you got to know Joe, the bartender. I'm like, I know Joe. Hey, Joe. Hey, Jeff. And I go in, don't I? More people would be able to go in. That's what I call the nice bouncer. The nice bouncer uses or because that lets more people in. So what if I had the mean bouncer that one night that I went? And I go up to the door and he's like, and I'm like, come on, man, let me in. He's like, all right, you got to know Joe. I know Joe. Hey, Joe. And you got to be rich. Well, shit. And, well, don't even, you got to dress. I don't care anymore. I'm out. I'm gone. So, and is the mean bouncer because you have to meet all of the requirements to get in. So less people will get in or more. Or you just have to meet at least one of the requirements. So of course you're going to get in. Right? Does that help at all? Or is the nice bouncer and is the mean bouncer?
Yeah, so what are we doing? What?
What do you mean? Are you out there? So, do you understand? It's an analogy to help you remember,
Okay.
and we'll always have less stuff.
I didn't know that my mic was on.
Oh,
I was just like,
oh,
shout.
you could have said so much worse. I'm in so many meetings where I'll say something and then I look real quick. Oh, thank God my mic was off.
No, I'm not. I'm aware of what I'm saying, but I'm saying I just got frustrated. Like, come on, Jeff, show us something. I want to learn.
Well, I mean, it's what I already showed you, right? So why was the and less? Because you have to meet both requirements. Less people could get in. Here,
Right.
you got to like the Chargers. I don't. Or you got to live in San Diego. Oh, shit. I don't do that either, so I'm good. I'm in La Mesa. Anyway. But the or bouncer would let more people in.
Yeah.
You guys see what I'm saying? So it helps remember what each thing does. If you remember which one lets more in, is my hope. Okay. Any other questions from homework? All right.
Wait, Jeff, wait a minute, hold up. So I'm trying to make sure I stamp this in. So when I look at the entire amount of people that live in, so I have to subtract the intersection.
What are we talking about? What?
Yeah, I see it. Like 25, and we subtract it to 12 to get to 13 in the
Yeah.
intersection.
Okay. Oh, you
Yeah.
mean going back to putting it together? Yes, exactly.
Right.
Whatever.
Right. I
how
just
much-
got to condition my mind to keep
Well,
going
because
over it. I'm a
how much-
repetitive learner.
How much can be in the San Diego circle? 25. You can't end
That's
up with
it.
more than 25 in the circle. It's
Glad
just
we
that,
did this.
that 12 is kind of a base for both circles. So that's why that's the key. That's where you start when you go to create a Venn diagram. You start inside, innermost. Okay. Woo! Anything else from homework stuff? You guys remember what's supposed to be happening tomorrow? Yeah. Supposed to be a quiz tomorrow. So I wanted to float this idea by everybody. Can we push that quiz off? Will anybody be upset
Absolutely not.
if we push? Let me go ahead and push that quiz until Wednesday.
Thursday.
I don't
Tuesday, thank you.
You want, did I hear Tuesday? You want Tuesday instead, or you want Wednesday?
No, Thursday.
Thursday.
Thursday would work.
Thursday
No,
will work.
Thursday.
Do you want Tuesday or Wednesday?
Thursday.
Thursday's
Wednesday.
I love you guys so much. So Wednesday it is.
Mhm.
I don't even hear the answers that are not part of what I gave as possible answers. I don't hear them. So I hear a lot of silence and a few Wednesdays. So Wednesday wins. Okay. If you don't want Wednesday, then we'll do it Tuesday.
Wednesday work.
Wednesday.
People just don't learn. It's amazing. People are still saying Thursday, and I'm like, oh, you don't want Wednesday, so it's Tuesday. I mean, learn. It's so Wednesday is what it will be. Okay. All right. So tomorrow we'll do some review stuff, but I need more of you guys to get done with section 1.8 and get started with section 1.9. Let me see. In fact, what I think I'll do, let me go ahead and say, yeah, I like this. Here, well, no, screw it. I'm going to stick with Wednesday, but it's only going to go up through 1.8. You guys understand? All right, so that'll be a compromise we make. All right. So tomorrow, more of you guys try section 1.8 out, have more questions. We'll do a quick little review, and then we'll hopefully get into chapter 2, but we're going to finish up chapter 1 today. Yes, we are. Anything left over? Any other questions about homework?
I had one back on 1/6. I was going to try. I realized we already did that one, but I was going back and trying to, do it again, studying for the test, whatever.
Sure.
The very first problem, I am probably thinking about it way too hard, but so I had it written down. Sorry, I want to make sure.
There you go. I got it.
Page
So
89.
here, page 77, P outcome is equal to the number of ways that outcome can occur
Whoa,
over the total
wait.
number of outcomes.
Page 77?
Right, but yeah, the homework assignment I'm talking about is on right after that, page, where'd it go? Did I lose it?
It's page 85 is the homework, right?
Yeah.
Right.
Okay.
And I was looking a few pages back for making sure I knew how to do it. So the problem is, I'm so bad at navigating this online textbook.
I understand. But it's right here, this one about the women and
Yes.
men.
So
Okay.
possible outcomes is two. Ways that outcome can come about.
Wait. You are thinking way too much about this. They tell you the answer to the first question already. What's the probability that you run into a female?
Just 51.5.
Exactly, 51.5%. So
Okay.
what's the probability you run into a male?
49.5.
Well, 48.5. Be careful.
Yeah, right.
Okay, that's done. Yeah, so you were definitely overthinking it because some people are telling me the answer is 50% and 50%, but that goes directly against what they just said.
Exactly. That's where I got to, because I got 1/2 and I was like, well, wait, it explicitly says that it's a little bit different than 1/2.
Yes, good. I like it. So it's like my little brother, coming back to my little brother. I don't know if I talked about him much. He's the one that thought, everything's 50-50. Chance it's going to snow tomorrow in San Diego is 50% because either it is or it ain't. But hopefully all of you disagree with that. If the weatherman came on and said 50% chance of snow tomorrow, we'd be like, they need to fire this guy. So wait, 50% chance of snow tomorrow, right? So yeah, that's the oversimplification of it that people sometimes tend to make. Since there's only two possible outcomes, they're each 50-50, but that's silly. One of them could be more likely than the other. And in this case, female is more likely than the other.
Okay. Yeah, I got to the point where it was 1/2 and I just fought myself into a corner.
Oh, okay. Yeah. Okay. But yeah, just you can't assume equal probabilities unless it says so in the problem.
Right.
Okay. I like it. Beautiful. Anything else? Any other questions? Homework? Everything's going fantastic on the homework?
Yeah, that was the last one I had.
Okay. All right. I'm not seeing anything else, so we're going to move on. Let's see. Let me stop sharing for a minute so I can get myself straight. See, 1.9. So we looked a little tiny bit at 1.9. We have definitely not gotten into this much at all yet. But I want to look at, we did look at this a little bit. So this was about newspaper circulation, right? So the table below shows the average daily circulation for newspapers in America. And of course, I already said this before, but what's the major conclusion you can draw from this table?
Papers are going down.
Yeah. So there's not as many newspapers in circulation. Of course, it makes sense because less people rely on the newspaper for news. Unfortunately, a lot of people rely on Facebook for news, which is terrifying. This is why Russia controls everything. But oh well. Now, something else is going to show up in this homework. It's going to be something called a scatter plot. Okay. all that means is plotting these points. Do you guys see how this is an XY point? So can somebody help me out? Somebody write down these points, right? So we've already done this kind of thing, haven't we? We did scatter plots earlier. We had to plot some stuff out, and then we changed the scale around a bit. Do you guys remember that? So this is nothing else. I don't think I'm just gonna plot a couple of these points. Let's plot these first two. Does somebody have the first two written down for me? Anybody? You gonna help me out?
What page is this on?
Let's see, this is page 119. All right, I'm gonna assume somebody's got those written down, or you can just look at it if you have the actual book. So if I want to plot those points, come here, little dude. All right, wait a minute. I gotta plug in my other technology. Hold on. There we go. Bluetooth mode. Bluetooth.
Bluetooth.
Sorry. Do. All right, guys. Everybody just can't believe how exciting this is. All right, let's see. So what was that first point? Somebody help me out. Oh, that's right. Arr, I got to do this too. Oh, technology is so exciting. All right. Get over there. Okay, reshare this. Okay, let me help myself if nobody's going to help me. 2001, 55.6. So I want to go 2001. So I could go ahead and just say this is 2001 here, if I was doing this right. Why is that there? That is weird. I have no idea. Okay. So 2001. In fact, what I could do for, well, screw it. This will be fine. 2003, 2005. It seems to be going odd years, 2000 and so forth. And the first point one, and then this, I can make my axis here. Now somebody help me out. Can somebody see the, well, I guess I could. I have my physical book too. So if you look back at the points, it starts at, where are you? There you are. Okay. So it looks like it goes from 55 points. So it goes 2001, 55.6, all the way up to 2015, 37.7. So let's see, 7, 9, 11, 13, 15. So I'm definitely going to make it there. But what do I want to make this scale? Everybody stay with me now. Stay with me. What do I want to make? I've got 1, 2, 3, 4, 5, 6 little tick marks. And I want to be able to show from 37.7 up to 55.6. So there's really nothing wrong with trying something and then realizing it sucks. So I could say maybe this is going to be 35. And then I'll basically want to make it up to 60. So if I go by 5s, let me stop right there. I really want you guys to get the idea of creating a decent scale. So I can kind of break. I don't have to start at 0. I don't. So 35, 40, 45, 50, 55, 60. Hey, what the shit? That was lucky. Right? I always try to start with a nice scale, and 5s is not a bad scale. I have to be able to show points that go between 37.7 and 55.6. You guys, we stop for a minute. Let me know if you have a question. Does anyone have a question? So I've got the years all fitting on the x-axis. I need all of these to fit on the y-axis. Why don't I want to go by 15, 35, 50, 65? Because then everything's going to be scrunched up. I want to try to use most of the space. So if I go by 5s, that seems to be pretty good.
Hey, Jeff.
Yes.
Does it matter when you're doing a graph like that? Does it matter? Like, I guess the question would be, when it comes to because you're doing a graph based off a time frame. So do you always put the years? How do you know?
Oh, well,
your-
what order? Are you asking about why I put the years down here?
Yes.
Okay. We know what order points come in, right? What order do points always come in? What's the first thing represent? Do you guys know?
Oh, I mean,
Time?
No.
so X, Y.
Right? So this
All
is
right.
the x-axis, and this is the y-axis. And they kind of tell me here, they kind of give it away. They put year there, but because of the way the table was set up, the first thing given was year, and the second thing given was circulation. So I know this is going to be the x-axis, and I know this is going to be the y-axis. Is that all right?
Yes, that's right.
There could be times where it doesn't matter which way it is. But it is true. I think I'm going to go back to your original question. You almost always will have time. If there is time, it will almost always be here because you're curious about what it looks like over time.
All right.
Right? So that's one way to look at it. But it's just because they gave me time first. So that's the x-axis part.
So it could vary depending on the way the question's being asked.
Yes, totally. Yes. Yep.
All right.
Like it. How's everybody doing out there? Are you guys, you got to let me know. Scale is a really important thing. I mean, see, my scale is 5 and it's always 5. It's always 5. It has to be. And down here, my scale is 2, 2, 2, 2, 2. And now I just plot the points. So the point 2001, what is it, 55.6 is roughly right there. And then so forth. And then it goes to 2015, 37.7, which is about right there. Right, so then you can plot all the points. In fact, let's see. Might as well do it.
55.6.
Let me see. 55.2 for 2003. That barely changed. 53.3. Yeah, and this is going to be 52 and a half here, right? So 53.3, it'll be about right there. 50.7 is just above there. 45, what is it? 45.7 is going to be about right there. 43.4 is going to be about right there. 40.7, how did I miss something? Oh no, that's the, I am missing something. What did I do? 2001, 2003, 2005. Oh, I missed, oh, that's good, Jeff. I skipped 2005 entirely. Oh, this is good, Jeff. This is a master class in how to teach. Let me get this out of here. All right. Sorry. Everybody gets the idea, hopefully. You just plot the points. So 2005 was supposed to be at 53.3. 2007 is at 50.7. 2009 is at 45.7. 2011 is at 43.4. 13 is 40.7. And 2015 is 37.7. So kind of it's definitely not linear, right? Oh, this is going to be exciting. Let me see if I can do this. It's definitely not, it doesn't start off linear, and then it sort of becomes linear. Oh, Jeff sucks at this. Just make that big. There you go. All right, that's enough. I'm kind of assuming that everybody's able to plot points. Right? Do you understand? This is the x-axis, this is the y-axis. This is how much you move over. This is how much you move up or down. And then I can see what shape it's in. And back when we were talking about linear versus exponential, you had to plot points then also. So all a scatter plot is, we haven't yet heard that words before, those words like this. It just means plotting a point. Whoa. Hello. Okay. So that's not that big of a deal. We've done stuff like this before. All right, I'm going to clear all my chicken scratch. So you're going to have probably in the homework, you're probably going to have to create your own scatter plot.
Jeff,
Yes.
you mentioned linear and exponential growth. Is that what you just said?
Definitely.
Okay, so exponential growth, is that how you pronounce it?
Exponential. Just like
Exponential.
exponent.
So I'm catching up on the homework and I'm all over the place, and I hit a question where it's asking, is the chart provided, it's breaking down in tabs, going down, and it's
Yes.
asking, is it a linear growth or
Linear.
linear growth?
Linear.
Linear growth
Sure.
or exponential growth. And I guess once you get once you figure out what the decimal is, then I would put it in a graph to find out if it goes.
No. Linear just means you keep adding the same amount from step to step. Exponential means you keep multiplying the same amount. That's it. You don't have to graph it.
Okay. That's what I got then.
And somebody made a good point in the chat. I kind of added the line in. The scatter plot is just the points. I wanted to add the line in just to bring us back to what we did earlier.
But
This is
hey,
obviously
Jeff,
not.
Jeff,
Yeah, hold on just a minute.
all right.
This is obviously not linear because it starts off with a little bit of a curve to it. But I can't say it's exponential. I don't know. It's just definitely not linear. That's all I could say. That's the only point I wanted to make by drawing that line. Go ahead, Sal. Go ahead, Sal.
Linear.
Linear.
Yikes. Right. I guess I have to enroll in English class. But shit.
Yeah.
So
Linear.
Linear. All right. So why do you bring those terms up on this graph? Like, how is it? It's
How can we tell? So
I know
I created
go
the
ahead.
graph. Let me answer your question.
All
We
right.
created the graph, and we can step back and see that this is not linear. How can I see that this is not linear? Because the points are not connected by a straight line, are they?
No, they're not. You're right.
There you go. So to be linear, it has to be a perfectly straight line that connects the points. And I can see here that it isn't.
That it isn't. All right.
So all I can say is it's not linear. I have no idea what it is, but I know it's not linear.
And you said back to exponential growth, you said that the number is being times by the same constant number.
Yes.
It's the same number. It's the same constant number, just that. So linear growth is just
Adding the same amount.
Adding the same amount.
If I saw a table that looked like this, oh, get out of there, 6. What amount do I keep adding?
You're going by
What amount?
by one. You're adding by tenths, right?
Well, no, 20.
By
I had
20.
20, at
Oh,
20,
40.
at 20. So this would be linear because I keep adding 20.
All right.
That's all. Every step I take here, it's up by 20 there.
And exponential growth, can you just give me a little side note?
So exponential, let me see if I can draw. Let's see. That would be a miracle if I could suddenly draw. You're all like, that would be nice. All right, be quiet. So if I had something like this, let's see if I can do this real quick. So if I had something like, sure. Well, if I make it really easy, it's kind of silly. But oh well. Let's see. Yeah, I might as well just make it easy. Why not? That's obviously not linear, right? Because here I added 4, and then here I'm adding 8. So I already know it's not linear, but is there a number that instead of adding, is there a number I keep multiplying by?
So adding, it would be an even number. It will be the same number that it gets at. And when it's multiply, it's going to increase, but at a different rate every time that it increases.
It's going to be growing faster, but of course, what do I keep multiplying by?
By 2.
By 2. So this would be exponential growth because I keep 2, 2, 2, 2. I keep multiplying by 2 every step. So that's
All right.
exponential growth. Yeah. Okay. So that was a good review of that section. I like it because I brought it up. You're right. So might as well talk about what that is again real quick. And this one is not exponential or linear is my guess.
Yeah.
Okay. So I'm going to clear all this.
And with the graph, when you're making a graph, you always start from the left to the right and from the bottom to the top, or when you're breaking down numbers, like let's say you're doing a graph just based on math and years. So for the X, you're gonna go from let's say if I wanted to grab something back from 2013 or 2012 all the way till 2020, then I'm gonna go from 12 to 20. And then what about the months? If I'm trying to calculate the months into those years, would I be going from?
That would be a graphical thing. That would be just a conversion. I don't understand. So you'd have to have like year versus population, or year versus, something that changes per year. You could have 1 month, 2 months, 3 months, and then length of your pet fish or something. Something that would change over months, you'd have a monthly scale. Something that changes over years, you would have a yearly scale. So I'm not.
All right, just disregard that. I was just
Okay.
curious, and I
I'm
figured
with
I ask. All right.
Sure. All right, I'm going to clear all this. Okay. I don't know what you're doing there. What is this? All right, good. All right, so now I want to talk about a few definitions. And these are things you've probably heard of before. But a population, so very often in statistics, for example, if we wanted to say something about all Grossmont students, does anyone know how many total Grossmont students there are? Or anybody have a good guess? No? Anybody? No, not even a guess? All right, so I think right now there's...
I'm going to say 5,000 final answer.
Oh, I see. All right. You should have used a lifeline. Let me see. Hold on. Somebody else has got. Oh, this is interesting. All right. I guess you guys are going to be a little blown away. Right now there's about 16,000 Grossmont students. In a normal year, we'd have 19,000 Grossmont students. This is obviously not a normal year. So we have about 16,000. So if you ever parked on campus, you realize now why it's so hard to find a parking spot. Okay, that's good to know. If we wanted to say something about all Grossmont students, do any of us have time to talk to 16,000 people? If you do, that I am jealous. If you do, that means spend that time on homework. What the shit? Okay. All right. Don't hit you talking to 16,000 people. So what do we do in statistics, obviously? Instead of talking to everybody, we have a sample. So is anybody paying any attention to the upcoming election, for example? Do you guys know there's an election coming up? Sadly? I'm sorry. All right, I'm not going to touch that. I'm not sure what that means. I'm very happy there's an election coming up. Is anybody going to vote for the first time? I don't know if I already asked you this question. Anybody voting for the first time?
Yes.
Let me see. I get a chat. Somebody is. Okay, a couple people at least. I don't want to ask if you're not voting. That is an option. That is completely legitimate option. But what the shit? You should really get involved. Lord. Let me see who's chatting at me. All right. I didn't tell you who to vote for, did I? I don't care who you're going to vote for. Vote. I don't care. Anyway, sorry. I'm trying not to preach at you. So if you look at any of these polls that are done, the reason people distrust them is because they don't understand statistics. Of course they don't talk to every American. Of course they don't, because they can't. How many people, how many registered voters are there? Does anyone have a guess? Huh?
Tons of people. I mean,
Yeah, literally. Yeah, if you put them all in on a giant scale, it would definitely be tons. There's 200 some odd million registered voters. So of course they're not going to call all of them, right? But it's legitimate to take an appropriately sized sample. So how big of a sample do you think? So a sample is the group that you pick from the population to represent your population. So if I used you guys as my sample and then asked you who you're going to vote for, why might not be a good sample to talk about all of America?
Because we're just in San Diego.
Exactly. You're geographically located somewhere so that you're a certain age for the most part. You're going to college. You're all these things that could bias the results. Are you guys?
Hey, Jeff.
You guys heard the word bias before? Yes.
wouldn't you think that it would make more sense to put an age limit on how people can vote? Like you have to have a criteria, just because there's people out there voting with no clue on what they're doing.
Wait. So that's a little bit beyond our discussion. That's
Yes,
a very interesting discussion, but it's more like for a political science course.
Yeah, I'm just saying, like there's people that don't vote and there's other people voting for them, or the people don't have enough education to even understand what they're voting for, and they're just voting like based off what their wave is, like.
Yes, I'm with you, but that's outside the scope of what we can talk about, but I agree with you to a certain extent. Holy shit. And now I'm just getting a homework question. I'm going to have to come back to that. You've missed your chance for today. I love you guys so much. We got to stay on. We got to stay focused. Okay. So you bring up some good points, Sal. That's beyond what we need to talk about here, right?
All right.
I've completely forgotten where I was. So we got the sample. We want a representative sample. So how could I possibly pick? How do you think they pick a sample to represent all of America and how they're going to vote? Could I pick just people that I know if I know people in every state? Is that good? Would that be representative? If I knew somebody in every state and I asked them how they're going to vote, would that be good?
It's better than people just in one state.
It's better, but is it good?
No, randomly is better.
If they're exactly, you're right. If they're friends of mine, it's very likely that we have similar thought processes, right? It's very likely, not completely true, because I do have friends that have very different opinions than me politically, but most of them will share my political ideology. That's one reason why we're friends. Are you with me? You all understand, I think, what I'm talking about, especially if you're kind of passionate about politics. Anyway. So even though it's better, I like that because it represents different states. Andrew, like it. So it's got to be truly random. It's got to be truly random. So you have to pick people kind of blindfolded in a sense, right? So there are. Anyway, I don't want to go too deep into this because we just talked about the basics. So we have a large group we want to say something about. That could be America. And then we have a subgroup that we pick that we need to be representative of the whole population. So you can think of easy examples where it's not going to be a good representative sample like we came up with already. My friends, stuff like that. Somebody's making a lot of noise out there. Somebody's chatting at me. Oh, geez. I love it. Is somebody trying to help Ruben? I appreciate that. Okay. So looking at this. So in the case of the newspaper curriculum, circulation numbers.
Where are you heading with the? I mean, are you still talking about the like the voting, or your
No. So that was a quick example about population and
population?
sample and picking a good sample. So that was just an example.
So what sample do you think will be good? I mean, what's your perspective?
So see, and that was a discussion I was about to launch into, but that's beyond the scope of this class.
Okay, all right.
I like it though. So there are ways to choose. There are ways to set things up so you get a good representative sample. That is kind of like what you would talk about in 160. If you're going to take statistics next, you go a little bit deeper into it. We're not a 160 class, so we're not going to talk about everything they're going to talk about. But that's an excellent question to think about if you are going to take statistics. So coming back up.
Statistics says, yikes. Jeff, don't you think, well, there's statistics in everything, like finances and equity and everything. And when you're running a business, you need to know how your business is doing on a year-to-year base. And then, right, like it's important to have a time frame of like a loss or a positive number in your business. Wouldn't you say that it's important to learn? Never mind. I don't know.
Everybody should know statistics. We are bombarded by statistics, and politicians and other people know that on the whole, Americans don't understand statistics. They don't understand percentages. They don't understand these things.
Well, that's why they're in debt. And that's why.
Let me finish an idea.
Okay.
So they will say things that make things sound a certain way, knowing that people don't even know how to check it out, to check out what they are saying.
Yeah.
So this is why I appreciate that you guys are in a class where we will discuss some of the basics, and maybe some of you guys will take statistics, and then you won't be so easy to dupe. That's what makes me so sad nowadays. All right, there's a whole thing going on in the chat. I like it. Okay. So let's focus. Coming back to this problem, the table below shows the average daily circulation for newspapers in America. Can somebody tell me what the population is for that problem? What's the group? What's the entire group? What's the population for this problem this year?
Newspapers in circulation from 01 to 15.
Yeah, newspapers in America. I like it. From 01 to 15. I like it. So that would be the population. All newspapers. So all is a really good word for population. All newspapers in circulation from 2001 to 2015. I like it. Is everybody with me? So what would be a possible, I mean, this is kind of a very vague question, but what would be a possible sample we could take?
You find one of those old ladies who's a hoarder, and they'll stack newspapers in their house, like up to the ceiling. That's probably only for like one town, but it's probably pretty good.
That would be interesting. So pick the worst hoarder in each city. I like that. That's very creative. But so real quick, to get a little deeper.
Or you'll be able to just see anybody that has a subscription for mail, you would assume they're a holder, or take your bet on that and have an idea of how many people in the city are subscribed to mail, receiving mail. And that's a way that you'll be able to have a more accurate number of a total amount for the whole city.
Mail,
right?
you don't have to be registered to receive mail. It's you could talk to the newspapers and get circulation numbers directly from them.
Okay.
So one way to do this would be to randomly select different newspapers in a state. So maybe randomly pick 10 newspapers in a state and then contact them and get their circulation numbers. Is everybody with me?
I think so.
So randomly would mean put all the names in a hat and then pick 10 of them out. That would be one way to do it. You could put it up on a wall and throw darts at it and then connect red lines red thread lines and be like that scene we see in every crime scene. No, don't do that. Don't go there.
So,
But real quick, why
Professor,
would
sorry.
this be? Sorry.
Sorry. So if you're doing like this, and we were actually going to take this sample, would you be required to some extent to purposely collect like the largest newspapers?
That would
The
so
data
that's sort
on the
of
largest.
that would not be really representative, because that would increase the average circulation. Do you see what I'm saying? So if I only include
Yeah.
the largest circulated newspapers, then the average circulation would certainly be higher than it should be.
Right. Okay. Yeah.
I like it. But I mean, I like the way you're thinking, and everybody just calm down a little bit, because we're investigating this idea. So you don't have to currently know the best way to pick a sample. You do not have to know that right now. All I want you aware of right now is there are many ways to pick a bad sample. And just to start realizing how to identify why it's bad. Does it really represent the population? If there's anything about the way you pick the sample so that it doesn't really represent the population, that's obviously a bad one. So let's look at these suggestions they have. What about if I just pick the daily newspapers in the 10 biggest cities in the United States? Would that be good?
Well, it's only no, I don't even know
No.
what I'm about to say.
Yeah, that's sort of related to the question that was just brought up, right? The 10 biggest cities have a lot of people. There could be bias in one direction or the other about how many newspapers are circulated there. It also wouldn't represent all the possible newspapers. There will be small cities with their own newspaper that won't be represented then. So you guys see it? So what's most important right now is for you to realize that not every sample is good, and to start to see, how can I tell if a sample wasn't well selected? Because so often we see 58% of people think hydroxychloroquine is great, but they never say shit about who they talk to. How did they pick who they talk to? And we don't even know to look for that. You just sort of see the number and you react and you retweet or you read whatever the shit, and things blow up, and then people got to say, whoa, calm down. They talked to people they knew. Holy crap, or something. Are you guys kind of with me? So that's the level I want us all at right now, is to start realizing I should know what sample they used. How did they pick their sample before I even consider the results they got? If their sample sucks, screw their results. Their results might be right, but I don't have a clue. I don't trust it. I can't trust it if the sample sucked, because then maybe what they got was biased in one way or another. That's the level I want us at right now. It's just starting to realize that you got to be more skeptical when you see things like this reported. What about this one? One newspaper randomly chosen from each of the 50 states.
Yeah, that sounds fine.
That's better. But why is it still not
I mean,
great?
it's only 50.
Because it's only
50,
one.
but
It's only one. That's the key. So how could I make number 6 become much better? I think I already gave this away. No, if you use all, then you have the population. We're trying to pick a sample.
do like 10 from each
Yeah.
state.
You could do, or you could do it what's called proportional. So like from smaller states with less papers, you take less, and from larger states, you take more. That's what's called proportional sampling. All right, so that's a little further than we have to go, but I just want to start throwing some ideas into your head about different ways to pick good samples. Does everybody understand how 6 is an improvement, but it's still bad? The randomly is nice, but there's not enough that's randomly picked from the states. What about, obviously, number 7? Please
What
tell
are
me.
you aiming for, Jeff? Like when you have a question like this, like how do you make sure you try to guess it, not guess it, but use the formula? I'm sure that you're using a formula, right? To get
No,
the
no,
answer.
there's no formula here.
No?
Each situation, I can tell what the problem would be, right? Why is this one a problem? For the reasons I listed. The 10 biggest cities in the United States doesn't represent all the states. It doesn't represent all the possible newspapers. It would make the average seem more because I would assume that circulation is higher in the biggest cities. Right? No? So all you need to do for this problem is list out some of the potential problems with the method they have picked. So this one has definite problems. This one's better, but it still has problems. There's not enough papers from each state chosen, right? So I'm not saying there's one method that will be the best and that it'll be obvious that no, that's not true at all. There are methods that are better than others, but almost all of them have some problem, right? Which if you're going to write a journal article showing results of a statistical analysis, you have to identify what the problems could have been and how you try to overcome those. You have to. So any good thing about results of an analysis will have that in it. We realize this would be a problem, so we try to correct for it by doing this. That they have to address those things. All right. And again,
Okay.
I'm going a little further than we have to worry about with this homework, but it's a bigger issue. So I really appreciate that you guys are bringing up issues. I like it.
Hey, Jeff, when
Yes.
you're doing an analysis, do you do that on a chart or a graph, or it just depends on what?
Oh, so, I mean, that's something you'll learn if you take statistics, but I'm talking, an analysis could be take all the ages of the people in the classroom and then find the average. That is a statistical analysis.
Right.
That is a remarkably basic statistical analysis, but that is what it is.
Yeah, but you
You've
can learn.
calculated a sample mean, a sample average, right?
You can, yeah. Right.
Okay. Oh, I got a chat. Is this more about? Oh, well, yeah, that's one of the requirements. Let me see. Okay. So hopefully number 7 is an obviously silly one. You guys know what this word here means? No?
In context or like,
Yeah, in context, in the context of this idea, national media conglomerate.
Sinclair.
Yeah, exactly. Some parent company that owns a lot of different media, right? So anyway. So obviously that would be bad because that is too focused. That doesn't include enough of other things. Okay. So your sample, so here we go. You ready? Here's a definition you can write down because it sounds like you guys want something. You ready? So to have a truly random sample, every element in the population has to have an equal chance to show up in the sample. But as we see, even if you accomplish that, like number 6 accomplishes that, it still might not be representative enough. But that is the basic idea of a random sample. Everything in the population has to have an equal chance to show up in the sample. So number 5 doesn't do that. Number 7 doesn't do that. Number 6 does it. It just doesn't do enough. Okay, maybe. Now, this is an interesting one. Look at number 8. What if we took every newspaper in the whole country, we list them alphabetically, and then we take every 10th one?
But they're all possibilities, Jeff. Like,
Good, true.
It's all a random number. It's not an accurate number, but it's a possibility. How do you calculate a possibility?
I'm not calculating a damn thing here, right? It's just, let me ask you a couple things.
You want a ballpark of
Did
what?
every paper have a chance to show up in the sample in number 8?
We have no clue. I have no clue. Well, we might, and I don't understand. So
So if I list alphabetically, one thing they're missing in number 8 is which paper do I start with? So if I randomly choose a paper to start with, and then I pick every 10th one after that, then every paper had a chance to be picked. So right now I can see people on my screen. If I randomly pick a person, just randomly pick a person, and then every third person, including that person I started with, I pick, everybody had a chance. Because I could, if I start with Sal, who right now is currently right up in my upper top corner, and then pick every third person after Sal, okay, but I could have picked Linnell, who's right next to me, and then picked every third person. So everybody has a chance to show up in the sample. This is what number 8 does. So number 8 is probably the best option so far. I would like number 8 better if they didn't do it alphabetically, if they just wrote down all the names randomly. But number 8 has the most work, right? Can you imagine how many newspapers exist in the country? I don't even know if you guys have any idea about newspapers at all, right? You know, newspapers almost feel like 8 tracks to some of you guys. I'm almost certain you're like, they're still newspapers.
I know, like, yeah, like fuck.
No fuck. Stop that.
Okay. All right.
All right.
Sorry.
Let me see. You better be. Let me see. Oh, all right. So now we're going to start seeing how the book brings back stuff we've done in the past a little bit. So remember we did pie charts and bar graphs before, right? Remember those? So if you look at this shows the results of a 2015 survey. In what format do you read newspapers? So here's the results they got. So you can see print only, print desktop computer, all and so forth. How do you think you'd want to illustrate? Why would a scatter plot not be good? What do you need to be able to do a scatter plot? What did we need? What did we need up here? We needed points, right? 2001, 55.6. That was a point that I could plot. In this data down here, do I have points? Do you see number, comma, number that I could say? No, there's type and then a percentage. So scatter plot is obviously out. I don't see points that I could plot. What about pie chart?
That's called the scatter plot, Jeff. This right here. This
Definitely not. A scatter plot is what we did earlier where we plotted points. Scatter, plot. So points are scattered all over a graph. That's scatter plot.
Right.
When I plot points, that's a scatter plot. This is just a table. It's the table right there. See, next table. What was it? Anybody remember what it was about pie charts? All the percentages have to add up to be what?
100.
Yeah, and if you add these up, you'll get 62, 76, 81, 88. They add up to 100, which is kind of strange. Right? So you could use a pie chart, and what about a bar graph? A bar graph would work too. So the only time you can't use a pie chart is if these don't add up to be 100%, right? So I would say either one of these two would work.
Pie chart or bar graph. All right.
Do you guys, so obviously scatter plots out, but then they're bringing back the stuff that we did earlier this semester. You just got to remember that. How can you tell this data came from a sample rather than a population? What do they say that shows me it came from a sample? What do they say?
And can I ask you one? It's not what I know that we're reviewing, section, what is it, 109 or 18 today?
19.
19. And, I'm going to do the self-study just because I feel like self-study, I have to read up on it myself, and that's the way that I learn. But since we're looking at question number 9, and before you move on forward, pie chart and graph charts, bar graphs, pie chart and a bar graph.
Yeah.
Okay, 1 minute. Just give me a second.
So that's in an earlier section.
Okay, yes, and I understand. I'm sorry. So I'm just trying to make this quick so you can maybe answer the question now since it has a rise. So with a pie chart, you're going to want to use it when it comes down to percentages, and a bar graph when it comes down to decimals.
No,
I mean, oh, it's the same thing.
they could use either one because percentages are decimals.
Okay,
just-
yes, exactly. I know. I don't know why I said that, but
The
I'm trying
big thing, like I just said, the big thing, like I just said, is in order to use a pie chart, they have to add up to be 100%, because that would be a whole pie. Bar graphs don't care
bar graphs don't care.
because they just make their own bars. They don't have to add up to be 100%. They could be more because people could answer more than one thing.
Yes.
Okay.
All right.
So-
thanks. So
Number 10, notice they say it's the results of a survey, right? So that tells me that it was a sample, not the whole population. It's because it was a survey that was conducted. Okay, and they're not going to get every single person in the United States answering a survey. Blah, 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 blah. And of course, this thing, print newspapers are becoming a thing of the past. Obviously, does this data support that? Does that trend that we saw support that? Up here. Does, maybe it's too obvious, nobody wants to say.
Yeah.
Yes, so yes, obviously all this that we're talking about supports the idea that newspapers are going out. So they're trying to become more digital. Okay.
I mean, you would
So-
figure they're digital by now. Right?
Yeah.
I mean, you'd figure they'd be, up to date with the technology as it's moving when you're in a business like that.
Yeah. Okay. I want to preview well, let's see. There's a couple things we got to talk about first. I was going to preview the homework with you, but there's a couple things we have to talk about first. Let's do this. So this first problem, they give us 28 college students were surveyed about what source they are most likely to get news from. And I did the same thing with some classes a while back. I think I might want to create a survey for you guys to fill out, because one thing I ask you, has anybody ever heard of a website called Reddit? A few of you guys. And of course, I'm always curious, Facebook has basically become something for people that are over 35, I think.
I think
but
Facebook is just for dumb people. Well, it's not dumb people, but if it's time consuming and it's, you don't gain anything in return.
Okay.
And
It's not my point though, Sal. It's okay. So I like to ask students what they use. If they use Instagram, I think TikTok supposedly will be banned. I don't know. I don't even know what the hell's out there anymore nowadays. Pinterest, no. So if I wanted to create something called a frequency distribution right here, it's not that complicated, thank God. It sounds like it's going to be crazy. But all I would do, this might be one of the last things we do today. So if I have a category like the first category I see, let's make it social media. So let's count, if you just count, so the tally marks, this is kind of silly. You would make a mark for everyone. I don't know if I have to do that. So I see 1 social media, and then I see 2, and then I see 3, and then I see 4. So I got 4. Does that look about right? Social media, 4. So the frequency is just how frequently that showed up. That's beautiful. What a perfect name. Math people were normally really bad at picking names for things. And then I see internet. So let's see, I got 1, 2, 3, 4, 5. Bam. 6, 7, 8. 9, 9. It looks like 9, right? All right, let me stop for a minute. Is that a difficult thing? That's all it means. When it says frequency distribution, it means write down all the categories and then count how often they show up. That's all frequency distribution means. How is all the data distributed? So if we keep going, there's TV. And I'm going to skip the tally mark thing. 1, 2, 3, 4, 5, 6. So 6 TV people. And then there's radio. Wow, radio. Cool. I like it. So let's see. 1, 2, 3, 4. Ooh, 5. 5 radio people. I like it. And what's the last one I'm missing? Is there another one? Social media, internet, TV, print media. There we go. And I see 1, 2, 3, 4. Looks like 4. Let's see if I got everybody. I have no idea how many there are total. It's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So there's 28. I did 7 times 4. There's 28. What does this all add to be? 13, 19, 28. Thank God. Does everybody understand what I just did? I got 28 total here, which is good because there's 28 total here. Thank the gods. It always sucks when that number doesn't match this one. Like, who did I miss? How are we all doing out there? Is this better? This is something you can sink your teeth into better. So
Yeah.
making
Question.
Yes.
Roman numeral have to be in their tally marks.
This, you guys know tally marks, right? You guys okay with 1, 2, 3, 4, 5? Have you guys seen that
Right.
before? All right. That's all. You don't have to look how I didn't do them here because I really didn't
Oh,
need
yeah,
them.
that's not Roman.
That's not Roman,
Yeah, I got
exactly. It's sort of, kind of, but not really. Because 4 would be this in Roman,
And
right?
3 would be different. And, yeah.
Well, 3 would be this, so that's the same.
Yeah, that's my last name's a 3rd. Yeah.
Well, there you go.
All right.
All right. Let's see. So, if they ask you to create a frequency distribution for something, you just write down all the possible answers that you got and then count how many of each answer you got. So obviously, I can now very quickly tell the most common thing used is the internet. Now, what could I do after I've done this? I could create like a graph. I could create, so social media would go up to 1, 2, 3, 4, right? Social media would go up to 4. I could make a little bar graph. Internet would go up to 9. The bar would be really big. If I wanted to, I could do that. Okay. I love you guys. I love you guys. I got to clear all this so I can keep going. Well, wait a minute. What's it say down here? Number 3, use your distribution to write some conclusions. Oh, do you think there's enough data for your conclusions to be reliable? How many people did they talk to?
28.
Is that enough data to make reliable conclusions?
No.
Hell no. Okay. Right. So if it's like the commercial about the gum, and they say 4 out of 5 dentists would use this gum, and you're like, how many dentists did you talk to? 5. It's like, that ain't good enough. So hopefully they talked to thousands before they said that. Okay, maybe. I'm really worried about what number 4 is because I can't scroll up without losing what I've done
Jeff.
already. Yes.
Why is it not enough? The total 28 for data. Why is it not enough? If that's the amount that is being given.
This was, I can't look up at the moment. Hold on. So the beginning, they tell you 28 college students were surveyed. So do you think if they're trying to talk about all college students, or even if they're just trying to talk about all Grossmont students, Do you think 28 students is a large enough sample to represent all of Grossmont?
No.
No.
No. Let me ask you this. Considering Grossmont has about 16,000 students, how large of a sample do you think I should take before it's going to be representative?
At least half
No.
of the, no? You
Maybe
would need to,
1,000?
Say again.
Like 1,000?
Yeah, 1,000 would be really, really big, to be honest. Yeah. I'd say 100, 200 or so would be fine. So let me tell you this. Here's a neat little something. Has anybody ever heard of the website called Gallup? Gallup.com? Here, I'm going to show it to you. I'm going to clear all this stuff, and then I want to show you Gallup because it kicks ass. I'm going to clear this whole thing. I'm going to stop sharing. Go away. I'm going to look up Gallup real quick. We're going to be done in just a minute. I think we're over time anyway, so this will be the last thing we do. This is our first time I've kept you the whole time, I think. Oh, shit. What did I just do? Oh, duh, Jeff. Let's see if I could do this. No, shit. All right. Hold on, everybody. Where's your news, Gallup? Why did you change your website? There it is. All right, let me show you this. Bum, 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 bum. Let me move you guys back over there. Here we go. Real quick. So here's Gallup. Hopefully I don't have anything too weird open. Good. You can see they like keep track of the approval of our president. You could go to stuff like education, higher education, and they have these things like college alumni see room for job skill improvement. So if I pick, let's see if something sounds interesting. All right, let's look here. Black college grads report less support in college. They give the results. They talk to people. They give the results of how they felt. But if you look at the very bottom, Jeff, let's see, where are you at? Here we go. Survey methods. Do you guys see the survey methods? So then they tell me how many people they talk to. And this is a really huge, wow, this is a huge sample. 19,000, that's a huge sample. And then they boil it down to this many graduates. Anyway, so they tell me how many people they spoke to. They tell me how they picked them, how they talked to them. They tell me some basic stuff about the group. Anyway, that's what you always want to look at is how many people did you talk to? Is this seem reliable? Does it seem like a good sample size? Stuff like that. So Gallup is really good at this stuff. Also, another great website, 538. I don't know if has anybody ever heard of the website 538? I mean, this is crazy. I mean, right now they're focused on the election a lot, but they do statistics on sports. They do statistics on social things. They do, anyway, it's kind of crazy. So if you look at the election forecast, they did some kick-ass, nifty-looking stuff. They ran a bunch of simulations to see who would win. They plotted how many times Trump won, how many times Biden won. So it's sort of like running an NFL simulation between two teams on like Madden and then plotting how many times somebody won. Okay, I think that's enough for today. I've gone way beyond anything, but there's a couple websites. This one's really good if you're curious about politics and stats in general. They have all different ways of representing data. It's crazy. It's beautiful. But I'm going to stop sharing and I'm going to say officially class is over. If you want to hang out, if you got questions, hang out. We'll finish up section 1.9 tomorrow. You're welcome.
thanks. See you tomorrow.
All right. You guys all right? Anybody have questions? Just put the links in Canvas. Oh, good point, Ryan. I could do that. Yeah.
What are those? The sample ones you was just talking about?
The websites that I was talking about. Yeah.
Yeah.
Somebody was saying I could. I'll put them up in here in Canvas in case somebody wants to check them out.
And then also our quiz is going to be on, what's that, 5 to 8?
Yeah, 1.5 to 1.8. So tomorrow we'll do review first, and then we'll finish up section 1.9.
Like a winner. Have a good day, Jeff.
You too.
Interesting class today.
Yeah, it was all over the place. Is everybody else
Really?
out there okay? I'm going to head out if nobody has questions. All right. I'll see you guys tomorrow.